वेलकम अगेन। रिलेशन और फंक्शन की एक और क्लास में आपका स्वागत है। कुछ क्वेश्चंस लास्ट क्लास में हमने डिस्कस किए थे और कुछ आज डिस्कस करेंगे, है ना। तो 2 क्लासेस हमारे पास हैं रिलेशन और फंक्शन की। तो फटाफट हम स्टार्ट करते हैं रिलेशन एंड फंक्शन। कुछ प्रॉब्लम्स मैंने नोट किए हैं, उनमें से देखिए। सभी इंपॉर्टेंट और प्रीवियस ईयर के क्वेश्चंस हैं और ये वाला रिलेशनशिप काफ़ी इंपॉर्टेंट है। आर बी रिलेशन ऑन द सेट ए। What set A of ordered pair of positive integer. So set A of ordered pair of positive integer defined by relation xy related uv implies that xy is equal to uv, show that R is equivalence relation. जैसे we know that a relation is equivalence if it is reflexive, symmetric and transitive. So we have to prove that the given relationship is equivalence. So to prove that it is equivalence, we have to prove it reflexive, symmetric and transitive. So firstly we will start from reflexive. What is the definition of reflexive relation? A related to R. A or A related A like this, or both are equivalent. A related A element related to itself. So A related A xy is A and uv is B. So we can write xy related xy, A related A. Before and after we have A. So A related A, this will can also become xy. And what is the result? Xy, this into this is equal to this into this. So xy is equal to xy. We know that both are equal. It shows that R is reflexive. Correct. To prove it's symmetric. For symmetric, what is the rule of symmetric? We know that the rule of symmetric, A related B implies that B related A, ordered change. A related B to B related A. So therefore, we will write first xy related uv. It is equal to xy uv and replace the order B related A. B related A. So u into v is equal to x into y, because x comma y can written xy and u comma v uv. So therefore uv is equal to xy. Both are equal, which implies that xy related uv implies that uv related xy. A related b implies that b related o. Then R is symmetric. R is symmetric. And the main transitive. To prove that transitive, what is the definition? If A related B and B related A implies that A related C. A to B, B to C. So firstly you have given xy related uv. It is equal to xy is equal to uv and uv related wz value we can take, and it will become equal to uv is equal to wz, which implies that xy equal to uv and xy equal to wz, which implies that x comma y related by definition wz, because xy related uv can written xy uv, so xy can written x comma y, equal meaning related, and wz. It shows that R is transitive. Therefore R is an equivalence relation. Equivalence relation. If a relation is reflexive, symmetric and transitive, it is equivalence relation. I think it's clear. Very simple question. मूव करते हैं नेक्स्ट क्वेश्चन पर. नेक्स्ट क्वेश्चन हमारे पास है, if R1 R2 are equivalence relation in a set A, show that R1 R2 intersection is also equivalence relation. Correct? It is one of the most important question. R1 R2 are equivalence relation. Show that R1 intersection R2 is also equivalence. For reflexive, A related A. What is the reflexive? A related A. Correct? A related A. Since R1 and R2 are equivalence. Are equivalence relation. Why? Because it is given. R1 and R2 are equivalence relation. It is given. Therefore, when AA belongs to R1 and also R2 is equivalence relation, we can also write AA belongs to R2. For all A belongs to A. For all A belongs to set A, which implies that AA belongs to R1 and AA belongs to R2. Therefore, AA belongs to R1 intersection R2. For all A belongs to A. AA, which implies that R is reflexive. Clear? AA belongs to R1 and AA belongs to R2. Therefore, AA belongs to R1 intersection R2 because it shows that R is reflexive. For symmetric, by slow phase, we will start with slow phase. We have to prove if A related B, which implies that B related A. Correct? A related B implies that A related B. तो start करते हैं. AB belongs to R1 intersection because this is the main question. In AB belongs to R1 intersection R2. What is the meaning of this word? It means AB belongs to R1 and AB belongs to R2. So which implies that BA belongs to R1 and BA belongs to R2. It means BA belongs to R1 intersection R2, which implies that R is symmetric. One more times. AB, we start from here. A related B implies that B related A. We have to prove this way. A related B implies that B related A. So AB belongs to R1 intersection R2. Show that AB belongs R1 as well as AB belongs to R2. But R1 is equivalence. It means R1 is reflexive and symmetric. When R1 is symmetric, it means AB belongs to R1. It also BA belongs to R1 because R1 is equivalence. AB belongs to R2, but R2 is equivalence. Therefore, it also symmetric. So BA belongs to R2. When BA belongs to R1 as well as R2, so BA belongs R1 intersection R2. Or AB, we start from AB belongs to R1 intersection R2 and prove that BA belongs to R1 intersection R2, so R is symmetric. Very important question. And in third, we have to prove transitive. The rule is if A related B and B related C is implied that A related C. Correct? So we have to start. AB belongs to, same way, belongs to R1 intersection R2. AB belongs to R1 intersection R2 and BC belongs to R1 intersection R2, and we have to prove that AC belongs to R1 intersection R2. AB belongs to, we will start here, AB belongs to R1 and AB belongs to R2 here, and BC belongs to R1 and BC belongs to R2, correct? AB belongs to R1, we have start from A related B and B related C. Then we move to AC, BC belongs to, AB belongs to R1 and AB belongs to R2, and BC belongs to R1 intersection R2 imply that BC belongs to R1 and BC belongs to R2. Here we will start that AB belongs to R1 and BC belongs to R1, but R1 is equivalence, so therefore it is transitive. So AB belongs to R1 and BC belongs to R1. We can write AC belongs to R1. Why? R1 is equivalence, it is given, and AB belongs to R2 and BC belongs to R2, and R2 is given equivalence, therefore AC also belongs to R2, which implies that AC belongs to R1 intersection R2, therefore R is transitive. The relation is reflexive as well as symmetric and transitive, so we can say R1 intersection R2, R1 intersection R2 is equivalence relation. तो वन ऑफ द मोस्ट इम्पॉर्टेंट क्वेश्चन, बोर्ड 2024 में ये क्वेश्चन पूछा गया था. आगे मूव करते हैं. नेक्स्ट क्वेश्चन, ये रहा क्वेश्चन, एनसीईआरटी का क्वेश्चन, एक्सरसाइज का क्वेश्चन नंबर 4. 3 क्वेश्चंस लाइन में हैं. शो दैट द रिलेशन आर, नेम ऑफ द रिलेशन इज आर इन आर मीनिंग real number. A relation R defined in real number as, what is the relation? R AB is ordered pair of relation R such that A is smaller than equal to B. You have to check it is reflexive for symmetric but not transitive. Reflexive, transitive but not symmetric. The solution, you have to check the given relation is reflexive. For reflexive, what is the relation? AB such that, so the relation, what is the relation? A related A. So you have to write A is smaller than equal to A. Yes, every number either equal to A, every number is equal to itself, therefore R is reflexive. From inequality, it fulfills the one condition. For symmetric, A related B implies that A is smaller than equal to B, which implies that B related A is not true. R is not symmetric. Why? For example, if A is equal to 4 and B is equal to 2, तो देखो A greater than equal to B, यानी कि 4 greater than equal to 2, but 2 है ना is not greater than equal to 4. False. For transitive, A related B implies that A is smaller than equal to B, and B related C, तो B smaller than equal to C. तो A किससे स्मॉलर है? A smaller than B and B is smaller than C. which imply that A is smaller than equal to C, A related C, R is transitive. Only it is not symmetric, but it fulfill both condition, transitive as well as reflexive. Clear? There are 3 questions which move according to this, which are like this. The second question, one more question, same language, only this change. All 3 from NCERT. A is smaller than equal to B square. Third question, are AB such that A is smaller than equal to B cube. Check they are reflexive, symmetric and transitive. तो एक आध इसको भी हम चेक कर लेते हैं. R is equal to AB such that A is smaller than equal to B square. बताइए, चेक कर सकते हैं आप इस क्वेश्चन को कि इट इज़ रिफ्लेक्सिव, ट्रांजिटिव और सिमेट्रिक. तो स्टार्ट करेंगे. सबसे पहले आप रिफ्लेक्सिव से. वी विल स्टार्ट फ्रॉम द रिफ्लेक्सिव. द क्वेश्चन इज रिफ्लेक्सिव और नॉट. फॉर रिफ्लेक्सिव, A related A implies that A is smaller than equal to A square. Not true. If A is equal to 2, तो 2 never is smaller than equal to 2 is smaller than equal to 2 square. Correct. But if A is equal to, अगर आप रैशनल लेकर देखें तो 1/2 is smaller than equal to 1/2 का स्क्वायर, यानी कि 1/4. Not. It is true if A, B are integer, but not if A is rational number. But the relation defined on real number, so not reflexive. Not reflexive. For symmetric, for symmetric, A related B implies that A is smaller than B square, and B related A, B is smaller than equal to A square. It is not true. A is smaller than B square. If A is equal to 6 and B is equal to 3, A is equal to 4 ले लो और B is equal to 3, तो you can choose randomly number. तो 4 is smaller than equal to 3 square, but 3 A is smaller than equal to B square. Yes, A meaning 4 is smaller than equal to 9. करेक्ट है. अब आपको चूज करना है B is smaller than equal to A square. तो B is 3 is smaller than equal to 4 का square 16. It is correct in case of integer, and there are many integer when it is not correct. You can choose another value like this. A is equal to 4, B is equal A is equal to 3 सपोज किया, और B is equal to 10. तो देखिए A is equal to 3 is smaller than equal to 10 square, and what is B? 10 is smaller than equal to 3 square. Not true. If any one you can prove any one is wrong, so it is not correct. So R is not symmetric. If any one condition is not satisfied, so the whole argument is untrue. And we can also check for transitive. A related B, you have to choose A is smaller than equal to B square. B related C, B is smaller than equal to C square, which implies that A related C, A is smaller than equal to C square. It is not correct. Why this? A is smaller than equal to B square, and B, so B we can put here B, so it become A is smaller than equal to C4, but not C square. So R is not transitive. If you have any problem, so you can prove like this. You have to choose some pair where A is smaller than equal to B square and B is smaller than equal to C square, but A is greater than B square. Like if A is taken 16, B is taken equal to 5, and C is equal to 3. You can choose like this. So when we write A is smaller than equal to B square, so 16 is smaller than equal to 5 square, true. B 5 is smaller than equal to 3 square, but यहाँ देखिए A 16 is smaller than equal to 3 का square. It is not correct. 16 not smaller than 9, so it is not transitive. So this relationship is not, in case of A smaller than equal to B square, it is not reflexive, not symmetric, not transitive. Similarly, you can prove this relation. It also from the NCERT. ये NCERT का सेकंड क्वेश्चन था और ये NCERT का 5 क्वेश्चन. ठीक, तो नेक्स्ट मूव करते हैं नेक्स्ट पर. हमारे पास नेक्स्ट क्वेश्चन है जी वाला. लेट L be the set of all line xy in a plane. L represents set of line in a plane, and R be the relation in line defined as L1, L2, L1 parallel to L2. Show that R is equivalence relation. It is very simple question. You have to prove parallel relation is equivalence relation. Parallel relation, equivalent relation, congruent relation, equal relation, always equivalence relation. So for equivalence, we have to firstly prove reflexive, A related A. So you have to use L related L like this. So L implies that L parallel to L. A line is parallel to itself. A line parallel to itself. This line is parallel to itself. R is reflexive. For symmetric, L1 related L2 like this. So L1 parallel to L2. If L1 parallel to L2, तो L2 also parallel to L1. तो L2 related L1, meaning R is symmetric. Very simple. R is symmetric. Very simple. It's a very simple question for transitive. L1 related L2 implies that L1 parallel to L2, and second is L2 related L3 implies that L2 parallel to L3. L1 parallel to L2, L2 parallel to L3, which implies that L1 also parallel to L3, L1 related L3, which implies that R is transitive. Therefore, R is reflexive, symmetric and transitive. Therefore, R is an equivalence relation. This is the simple question. Now we have work on the second part. Find the set of all line related to line. This is the word, the set of all lines related to lines y is equal to 2x plus c r. Related, here the related word represent what is the relation in this question. Relation is parallel. The name of relation in this question is parallel. So you have to write all line related meaning parallel to given line. And if two lines are parallel, their slope are equal. Line always in form of y is equal to mx plus c, where m represents slope. So therefore, any line which related meaning parallel to this line having same slope, so 2x and c is any value, any intercept on axis. So you can see any c, 2x plus 4. So you can write any c is any real number. Or you can also write like this, 2x plus k, or k is any real number. So you can take any number related meaning parallel, and parallel slope are same. Slope are same. Parallel line have same slope. Parallel lines having same slope. So therefore, any line related to 2x plus 4 having same slope. So 2x is same, and this replaced by any constant c or k, which you are comfortable. Clear? Next question. One more question. A relation 2024. A relation on set. In this case, we have given a set 1, 2, 3, 4, 5. Is defined by R x, y. What is the relation? R is equal to having ordered pair relation x, y such that mod of x square minus y square less than 8. Check whether the relation is reflexive, symmetric and transitive. Very interesting question. So we move to start. For reflexive, what is x related x? Both replace x square minus x square. What is x square minus 0? 0 always smaller than it. You choose any number like 1 square minus 1 square, 2 square minus 2 square, any 3 square minus 3 square, 4 square minus 4 square, 5 square minus 5. All are equal to 0 less than, so therefore R is reflexive. Correct? You have given a set, so you have to choose from the set. For symmetric, x related y implies that mod x square minus y square less than 8. We can take common inside the mod, so we can write y square minus x square. We can take minus from the mod, and in case of mod, minus become positive. So y square minus x square less than 8. It represents y related x, therefore R is symmetric. X square minus y square less than 8. In mod, y square minus x square is also less than 8. And third, for transitive. What is transitive? X related y implies that x square minus y square less than 8 and y related z implies that y square minus z square less than 8, which implies that x related z is equal to x square minus z square less than 8 is not true. Is not true. How? Like this. When we use word x related y, so we can take 1 related to, we can choose two numbers. So 1 square minus 2 square, which is less than 8. Correct. Now we choose x related y, y related z. Choose 2 related 3. Implies that 2 square minus 1 2 2 4 4 square. So it become 12. Then x related z, 1 related 3. So what is 1 square minus 3 square? It is 8 less than 8. No, it is 8. It is greater. So it is equal to 8. So not this. So it is not correct. You can choose any one number, a greater number, 1 related 3, 1 related 2, 2 related 4. You can choose 4. So 4 square 16, yes. So 1 related 4, sorry. So 16. So, so it is 15. So R is not transitive. So you choose 1 2, 1 square minus 2 square, which is 1 less than 8, true. 2 related 4, 2 square minus 4 square. Then we have to try 1 related 4. So 1 square minus 4 square. So you can write again 1 square minus 4 square. So it becomes 15. 15 is less than 8. It is wrong. So last question. और इट इज़ ऑल्सो वन ऑफ द मोस्ट इम्पॉर्टेंट क्वेश्चन जो स्टार्ट किया था जहाँ से, ये उसी टाइप का क्वेश्चन है. A relation in product of natural number and defined by AB related CD is that AD in first into fourth and in bracket second plus third, and here it is change. The plus become multiplication and multiplication become plus. So it is simple question but slightly lengthy. We will start for reflexive. What is the relation? AB related CD. So you replace AB related AB. Where C you replace A, where D we replace B. Where C we replace A, where B we replace D. So AB, B plus A. B, where C we replace A, BA, and A, where D we replace B. AB equal to into B plus A is equal to BA into A plus B. Both are same. R is reflexive. The first two part very simple in all questions for symmetric, especially such type of question. AB related CD. Write down the same terms which is given. First fourth, first into fourth, second plus third. Second into fourth, first plus third. Now write down A related B related A. In case of single terms we have ordered pair. तो what is the rule? देखिए first to fourth, first into fourth, तो देखिए C into B और second plus third is equal to, this terms become into, तो DA and this term become in plus C plus B. Check. AD, yes, AD, C plus B, yes, B plus C, BC and CB both are same. You can write BC. Natural number, the summation of natural number is commutative. So DA can written AD, C plus B can written B plus C, which implies that R is symmetric. Correct, R is symmetric. Now for transitive, इसमें ध्यान से देखना होता है. Transitive, A related B, तो AB related CD. Write down the question. AD B plus C is equal to BC A plus D. Now AB BC CD related EF. What is the rule? First into fourth CF and second plus third. तो उल्टा करिए DE और C plus F. Now you have to prove AB related to EF. So you have to replace C and D. How will you work in this question? This is slightly different, like this. You have B plus C. To write down B plus C is shifted BC under B plus C. Same A plus D divided by AD. Here also D plus E by DE, C plus F upon CF. यही सोल्व कर लेते हैं. सेपरेट करिए. D अपॉन DE, E by DE, C by CF, F by CF. तो we have final 1 upon E plus 1 upon D, 1 upon F plus 1 upon C. Similarly B upon B plus C, यानी 1 by C, C upon B plus C, 1 by B, A upon A plus D, 1 by D, और D upon A by D, 1 by A. So this first, this second. If you add them, left to left, right to right, so here have we to add, we can solve here. Add first and second relation, add first and second. Left to left, 1 by C plus 1 by B left, 1 by E plus 1 by D right, 1 by D plus 1 by A, 1 by F plus 1 by C, 1 by C to 1 by C, 1 by D to 1 by D. So we have 1 by C plus 1 by B, 1 by A plus 1 by F. इधर एलसीएम ले लें. B plus C by BC, A plus F by AF. Cross multiplication, AF into B plus C and BC A plus F. Yes, it is become AB related EF. Clear? देखो, first to fourth and second plus third. So it is transitive. Therefore, we can write it is equivalence relation. So practice all these questions, and after few days you become master of the relation and function. आज के लिए इतना ही. From next class we will start with function. Thank you very much.